Hi everyone. Today we're looking at lesson 2 of our linear relations unit. I don't particularly like this lesson very much. I mean, some of the questions are very good, but I don't like the idea of the distance formula, and I'll tell you why, and hopefully you can agree with me. The distance formula is basically exactly what we did in the last lesson in finding the length of diagonal lines using the Pythagorean theorem. But all they're doing it now is putting into a formula. And if you're one of those people that likes to memorize everything and just have everything written down into a procedure, then the distance formula might work for you. However, on the other hand, if you understand how we calculate the distance of a diagonal line, I don't think you necessarily need an extra formula for that. Okay, in my opinion, it's like a formula for factoring trinomials. Well, if you understand what's going on, you don't really need a formula. You can just go ahead and do it. All right, so let me just show you, again, just to recap from last class, what's happening here. To get the distance of this line, okay, we first need to make a triangle here, and again, you don't necessarily need to make that triangle as long as you can calculate and visualize the lengths of A and B. And I think, using the last lesson, I think we can all, well, let me write the formula out here. A squared plus B squared equals C squared. I think we can all by now start to, even use mental math to get these distances. I can tell already that the distance of A is going to be 7 minus negative 5. So I'm going to go ahead and put that in brackets here. 7 minus negative 5, and then obviously square that. And then B squared is going to be 6 minus negative 3. 6 minus negative 3. Need another bracket here. Squared equals C squared. Okay, and really what I've done here, if you want to look at this, if you want to label these coordinates here, I can label this. I can label this coordinate as x and y, and I can label this one as x x2 and y2. Okay, just another way of labeling the coordinates. So what I've done here is I went x2 minus x1 squared plus y2 minus y1 here. So let me put these ones here just so you get it. Squared equals c squared. And then in order to get c, I need to square root both sides like this, square this whole thing, and now I have c equals, well, it's going to take me a while to write this out, x2 minus x1 squared plus y2 minus y1 squared. Okay, essentially this is the distance formula, but it's almost just as hard to memorize this whole thing here as it is just to do the question. And if you understand how to get this, you don't really need a formula. You still have to do all the hard work. It's not like it's saving you any time. So when you go down here and look at this distance formula here, that is exactly what I've just written up here. Okay, so let's go ahead and quickly do this distance over here. So the way I would do this, and probably the best way of doing it, is again, okay, what is the distance of A? Well, 7 minus negative 5, okay, that's 12. And if you need to write that down, that's okay. So let's go again. A squared plus B squared equals C squared. Okay, so then we have 7 squared, because A equals 7. B equals, okay, well, what's B? B is 6 minus negative 3. And if you need to write that down, that's no problem. Go ahead. But, you can use mental math as well and get 9 squared equals C squared. And now I have 49 plus 81 equals C squared. And finally I have, what does that be? 130 equals C squared. And then finally square root of 130 is the distance. Okay, C, or whatever letter you want to label that at. Let me put a C there. Now I think that's that's a lot easier than trying to memorize this formula and then trying to plug in numbers for x2 and x1. But again, everybody's different, so you should try both ways. So anyways, what this these questions here that basically take you through through what I just did up here, so you can try it again if you're still not sure what I did up here. Okay. And again, so I'm just going to jump right to the questions down here. I think that's a little more important than the formula themselves. So let's go ahead and do this. So if you cannot visualize the coordinates, go ahead and do the diagram and label everything. But I think that, you know, we can all come up with these distances: a squared plus b squared equals c squared, and sometimes I like to write it as the x distance squared plus the y distance squared equals the distance of the line squared, and that might help you keep you on track here. So let's go ahead and find out the distance for x. Well, that's 10 minus 2, so that's 8 squared plus, and again, be careful here because you have to be, you know, you want to subtract the bigger one, the smaller one away from the bigger one. So 3 minus 3 is going to be 6 squared equals d squared. And then here we get 64 plus 36 equals d squared. And your final answer should be the square root of what is 64 plus 36? That's exactly 100. So the distance equals 10. Okay. So distance equals 10. Okay, let's go ahead and do that again. So let's go x squared plus y squared equals the distance squared, and I have the x squared. Again, what's the bigger one? That's the bigger one, negative 17 minus 25. And, you know, go ahead and write it out. This one's a little bit harder to do in your head, so you want to go minus negative 25 squared plus, what's y here? So it's going to be 3 minus negative 5 squared equals d squared. Negative 17 plus 25, that's going to be 7 squared plus 8 squared equals d squared. 49 plus 64 equals d squared. So the final answer is the square root of 113 equals d, okay, because I have to obviously square root both sides there. Okay, let's do a word problem. Sometimes grids are superimposed on maps to find the distances between two locations. For example, to calculate the distance between two craters, Copernicus and Plato, on the Earth's moon, a coordinate system could be superimposed on a map of the moon. Ordered pairs would then be assigned to Copernicus and Plato to find the distance between the two craters. If the location of Copernicus on the coordinate grid is negative 89, so we can do a rough sketch. You know, it doesn't have to be very accurate here. So negative 89 and 226 might be somewhere up here, depending on your scale. Negative 89, comma 226. Again, I'll put a big C here for Copernicus. All right, and the location of Plato is 136 and 179. You know, that might be somewhere here. Put a big Plato here for P for Plato, and then 136, comma 179. Okay. Calculate the distance between the two craters to the nearest unit. They're not even telling us, I think, the units here. You know, maybe these are meters, kilometers. I don't really know. The moon has a lot of craters. Okay, and again, if you still can't visualize the triangle here, go ahead and make your right triangle, and this will be your x distance. This will be your y distance over here, and this will be your let's just call it d, because that's what we're looking for. So let's get right into it. So d a squared plus b. Let me change that up and use x and y to keep it consistent. So x squared plus y squared equals the distance squared. So the x distance is 136 minus And you know what? I'm going to stop doing these minus things again because I know it's going to be a plus now. I've done so many. 89 squared plus 100 and, well, no, 226 minus 179. And this one is obviously minus because it's not a negative, equals d squared. Okay, now I just got to do some math in my head. Actually, I'm not going to do it in my head. I'm going to get my calculator out. Okay, and do this on my calculator. I have 136 plus 89. Enter. Square that. Okay, large number. What was that? 50,625. So 50,625 plus 226 minus 179. Square that guy. 2209. So 2209 equals d squared. Okay, let me go ahead and add those numbers up. So I'm going to add that to 50,625. Hit enter, and then don't forget to take the square root. Let me write it out. 52,834 equals d squared. And then don't forget to take the square root to get your final answer. So I'm going to go second function, square root. And instead of typing the answer again, I'm just going to use the shortcut answer here. Bring that up. And it's 229.8, or I'm just going to say 230. 230 because it says to the nearest unit. All right, 230, probably kilometers, maybe miles, maybe meters, not really sure. Okay. Explain how we can determine if a triangle is right angled if we know the length of each side. Okay, this is just a Pythagorean theorem. It's going to be a right angled if and only if the two short sides, if I square the short sides and add them together, and that equals the square of the long side, then we know it's a right angle triangle. Okay, let's check this one out. So L is a point, 0, 1. M is -3, -3, and N is -7, 0. Prove that this triangle is a right angled triangle. Okay, let me go ahead and draw this one out. So I'm going to try and be a little bit neat here for this diagram. So let me plot all these. So 0, 1 is here. Let's make that 0, 1. That's going to be L. M is -3, -3. So 1, 2, 3, 1, 2, 3. There it is. So that's going to be M. -3, -3. And N is -7, 0. So 3, 4, 5, 6, 7, 0. Right over here is N. -7, 0. And what they're asking us is if this triangle here, do I have a, let me get some straight lines out here just to be a little more precise. Okay. There we go. Okay. And draw another guy. Whoops. Good. Oh, it didn't quite work out. That's okay. I'm going to do it by hand. Okay. So at first glance, it looks like it's not a right triangle because I'm not, that angle there looks to me like it's more than 90. But then again, my diagram could just suck, and I just could be off by a little bit. So I need to double check. So to double check, I need to see if the two short sides squared added together equal the long side. So let me find the distances of these guys. And that's going to be, let's make this A, B, and C. So A squared plus B squared equals C squared. Okay, this is going to take me a little while here because I need to exactly figure out the distances here. So what's the distance from here to here? This question actually, it gets a little bit tough because you have to use, in order to get each of these distances, you have to use Pythagorean theorem for all of the line segments. So I have to make a triangle like this, an imaginary triangle here. I have to make an imaginary triangle right here, and finally I have to make an imaginary triangle right over here to get all those distances there. So this question really, it's going to take me forever to do this because I basically have to do Pythagoras 4 times. I have to do it once to get the length here, another time to get the length here, and then finally to get this length, and then finally to see if all those lengths are also part of the right triangle. I have to do another Pythagoras. Let me do, you can stop watching here if you get the idea of this lesson, but if you're still not sure how to get these lengths, go ahead and follow me right now. So to get A, I need to, again, just focus on this triangle over here, because that for sure I know is a right triangle because I drew it to get the length of A. All right, so I'm going to use, you can get very confusing with all these A, B's, and C's here. So let's just make this, let's hopefully we can visualize the lengths here. All right, so the length of A squared should equal, sorry, not A squared here. Let me just change that up a bit. Okay, let's get this first triangle down here. What's this length here? We'll call it X, and we'll call this Y, and we'll call this one A. So X squared plus Y squared equals A squared. And I have, for X, I have -3 minus 7. That's going to be 4 squared. And then 0 minus -3, that's going to be 3 squared equals A squared. 4 squared, 16 plus 3 squared is 9, so 25 equals A squared. Square that. Okay, so at least I get an easy number here. A equals 5. All right, so what I just got was this length over here. That equals 5. So I'm going to go ahead and put that over here, 5 squared. Okay, let's get B. B is this one over here. And again, so let's pretend we have X squared plus Y squared equals B squared. So I have 0 minus -3, that's going to be 3 squared. 1 minus -3 is going to be plus 4 squared equals B squared. 9 plus, well, same thing again, 25 equals B squared. Square root of both sides, B equals 5. So B happens to be 5 as well. Okay, so what should happen now is that 25 plus 25 equals 50. And finally, basically, if I take the square root of 50, that should be the length of C, if indeed this is a right triangle. So let's see, we'll get length of C, and if it is root 50, we'll be in business. If not, it's not a right angle triangle. So let's go ahead and do that for C. Get another color here. Do it in red. Okay, so for C, again, we're going to X squared plus Y squared equals C squared now. And if you can kind of visualize what I'm doing here, that's the triangle I'm now getting right there. Okay, the length there is going to be from 0 to -7, so it's going to be 7 squared plus 1 squared equals C squared. 49 plus 1 is 50. 50 equals C squared. Ah, okay, there we go. It is the right triangle. My drawing just sucked. C equals the square root of 50. So there we go. So square root of 50 squared. There we go. It works. Okay. So this question is, again, way too long. So if you understand and you watch through this, hopefully you get what I did. I basically, just to recap, I took this triangle and made 3 more little triangles here. There's one, and there's the third one here. All right, just to make this a little more visual for you, okay, what I did was, if I have my axes and I have my triangle, and I'm trying to figure out if it's a right triangle or not, right, I need to get basically the lengths of all these, so I have to make extra triangles, something like this. If you can visualize this.